Good morning everyone. I am Nandita from grade 9B, here to do a presentation on the chapter number system. I have PowerPoint presentation ready with me, which I have prepared. Let's look into it and learn the chapter.
Good morning everyone. I am Nandita from grade 9B, here to do presentation on the chapter number system. First, let us discuss the definitions of the different types of real numbers. Whole numbers. All the counting numbers including 0 together are called as whole numbers. For example, 0, 1, 2, 3, 4, etc. Natural numbers. All counting numbers are called as natural numbers. For example, 1, 2, 3, 4, etc. Fractions. A part of whole or collection is called as fraction. For example, 1 by 2, 3 by 4, etc. Integers. All the negative numbers and positive rational numbers are called as integers. For example, -1, 1, 0, 2, -2, etc. Rational numbers. A number which can be represented in the form of p by q, where q is not equal to 0, is called as rational number. For example, 1, 2, 3, -1 by 2, -3 by 5, etc. Irrational number. A number which cannot be represented in the form of p by q. Now let us discuss deep about the topic number system. First, let us discuss about number line. Every point on the line represents real numbers. We can see the image which is represented on the number line. In the number line, we have positive integer and negative integer. In the center, we have 0. Now let us discuss about successive magnification. We can see the image of successive magnification. For example, 3.65 is represented in the image. Now let us move to the rationalization. Rationalizing the denominator. If the denominator of a fraction contains a term with root, a number under a radical sign, the process of converting it into an equivalent expression with rational denominator is called as rationalization the denominator. Rationalization is the process of transform a denominator into a rational number is called as rationalization. We can see the table in which we can rationalize the denominator. For example, to rationalize the denominator of 1 divided by root r plus s, we multiply this by root r minus s divided by root r minus s, where r and s are integers. Now let us move to the exponents with integral powers. We can see the different types of laws of exponent. For example, product law, quotient law, power law, reciprocal law. This ends up with our chapter number system. I hope you all have understood the number system chapter. Thank you everyone.
Good morning, sir. Let me introduce myself. I am Srinivas from 9th class. In this video, I will be explaining about polynomials chapter. Let's start. In polynomials chapter, there are some important topics. They are constants, variables, algebraic expression, terms, polynomials, and degree. Constants. A symbol which is having a fixed numerical value is called constants. For example, in this equation, 5 minus 2 plus 3 minus 2 are, for example, for constants. Variables. A symbol which is assigned different numerical value is called variables. For example, x will be assigned with 2, 3, 4, 5. Algebraic expression are combination of constants and variables with mathematical operations plus and minus is called algebraic expressions. For example, 5x cubed minus 2x squared plus 3x minus 2. Terms. The several part of the algebraic expressions which are separated by mathematical operations. For example, plus and minus is called terms. In the example, 5 minus 2 plus 3 minus 2. Polynomials, an algebraic expression which is involved with variables and non-negative integral power is called polynomials. Degree. Polynomial in one variable which is having highest power is called degree. For example, x power is 3. Here x power is 2. Thank you.
Good morning, my name is Wasfiya and I am from grade 9th D, and today I will be speaking about the chapter Areas of Parallelogram and Triangle. So basically, parallelogram is a quadrilateral whose opposite sides are parallel and are equal, and triangle is a shape with 3 sides. The formula to calculate the area of a parallelogram is base into height, and the formula to calculate the area of a triangle is half into base into height. And in this chapter we have discussed about many theorems, and the 3 most important theorems are theorem 1, theorem 2 and theorem 3. The first theorem says that any 2 parallelograms which lie on the same base and are between the same parallels are equal in area. That means here the 2 parallelograms are ACEF and BDEF. They lie on the same base, that is EF, and between the same parallels, that is AD and EF. So they are equal in terms of area. The theorem 2 says that any 2 triangles which lie on the same base and are between the same parallels are equal in area. That means here the 2 triangles are ACD and BCD. They lie on the same base, that is CD, and between the same parallels, that is AB and CD. So their area is equal to each other. And we can even see another triangle, that is ACE. It lies between the same parallel but doesn't lie completely on the same base. So this is not equal to the other triangle in terms of area. The theorem 3 says that any 2 triangles whose area is equal and which lie on the same base are even lying between the same parallels. That means here the 2 triangles are ADB and CBD. It lies on the same base, that is BD. That means AC is parallel to AD. So these were the 3 theorems on which the whole chapter is dependent. Thank you.
Hello everyone, I am Bhagyashree of grade 9B, here to present topic on circles, which is guided by our mathematics teacher Lingraju sir. Now let's look into the circles. Before starting our presentation, let us look into the criteria of a chapter. In this chapter, we will learn about the key terms related to circles and the theorems related to circles. Now let's start the presentation by saying the key terms of the circles. Circle. Circle is a set of points that are equidistant from a fixed point, and radius. Radius is a distance between center of circle to any point on the circle. Chord. Chord is a line joining any 2 points on a circle AB. Diameter. Diameter is the longest chord of a circle. This passes through center of a circle. Now let's look in a diagram. This is a circle where this is a radius and COP is a diameter, and this is a radius. AB and CD are a chord of a circle. Now let's look what are sector and what are segment. Sector. Sector is a portion of a circle formed between 2 radii and an arc. Sector is formed when this is a 2 radii and this is the arc. This arc is called minor arc and this is a major arc. Major arc and 2 radii form the major sector. 2 radii and the minor arc form the major sector. Now let's look into segments. Segment is a portion of a circle formed between a chord and an arc. This is a major segment and this is a minor segment. This is a chord AB and this is a major arc, and the chord AB forms the major segment, whereas the chord AB and minor arc form the minor segment. Now let's look into the theorems related to circles. There are 12 theorems related to circles. Let's look into first theorem. What does it state? Theorem 1 states that equal chords of a circle subtend equal angles at the center. It states that AB and CD are equal chords and they subtend equal angles at the center, where AOB is equal to COD. Now let's look into Theorem 2. Theorem 2 states that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. It states that AOB is equal to COD, then the chords are equal. Now let's look into Theorem 3. Theorem 3 states that the perpendicular from the center of a circle to chord bisects the chord. Here, OC is a chord which bisects AC and BC. Here the OC acts as a perpendicular from a center of a circle and it divides the two chords AC and BC. Now let's look into Theorem 4. Theorem 4 states that the line drawn through the center of a circle to bisect a chord is perpendicular to chord. It states that AC is equal to CB and OC is a perpendicular line. Now let's look into Theorem 5. Theorem 5 states that there is only one circle passing through the given non-collinear points. In this, ABC are non-collinear points and we can find only one circumcircle forming through this cyclic quadrilateral. Now let's look into Theorem 6. Theorem 6 states that equal chords of a circle are equidistant from a center, which means AB and CD are equidistant from a point O. Now let's look into Theorem 7. Theorem 7 states that chords equidistant from the center of a circle are equal in length, which means AB and CD are which are equidistant from a center of a circle are equal in length, which means AB and CD are equal in length. Now let's look into Theorem 8. Theorem 8 states that the angle subtended by an arc at the center is double the angle subtended by any point on the remaining part of the circle. Means AOB is double the angle of ACB. Now let's look into Theorem 9. It states that angles in the same segment of a chord are equal. AC and BD are same segment of a chord where ACB is equal to ADB. Now let's look into Theorem 10. It states that if a line segment joining two points subtends equal angle at two other points lying on the same side of line containing the line segment, the 4 points lie on a circle. Means ACDB lie on a circle if the line segment joins them. Now let's look into Theorem 11. Theorem 11 states that the sum of either pair of opposite angles of a cyclic quadrilateral is 180, which means angle A plus angle D is equal to 180 and angle B plus angle C is equal to 180. Now let's look into Theorem 12. If the sum of a pair of opposite angles of a quadrilateral is 180, then the quadrilateral is cyclic. It said that angle A plus angle C and angle B plus angle D is 180, then the quadrilateral is cyclic. We can prove it by angle A plus angle C is equal to 180 and angle B plus angle D is equal to 180. Total it forms 360 degree, which is the sum of a quadrilateral. By this we can prove that sum of pair of opposite angles of a quadrilateral is 180, then the quadrilateral is cyclic. Thank you.
Good morning everyone. My name is Krupa. I am studying in grade 9C at Akshada Public School. Today my topic is triangle. What is triangle? Triangle is a closed figure which is formed by three non-collinear points. Now we are going to discuss about the congruent figures whose shape and size both are the same. Here we can see that the two triangles with the same radius. This is known as the congruent circles. Here I have two triangles, triangle 1 and triangle 2, with the same size. I am placing the triangle 1 on triangle 2. We can see that the triangle 1 covers the triangle 2. This is known as congruent triangles. Now we are going to study about different congruency rules of triangle. First one is SAS congruency rule. It means side angle side congruency rule. Two triangles are congruent if two sides and included angle of a triangle are equal to two sides and included angle of the other triangle. In figure, we can see that AOD and BOC are the two triangles. In given, OA is equal to OB and OD is equal to OC. Now, AOD angle is equal to BOC. This is because they are vertically opposite angles. By SAS congruency criteria, we can prove that AOD triangle is congruent to BOC triangle. Next one is ASA congruency criteria. It means that angle side angle congruency rule. Here, two triangles are congruent if two angles and included side of one triangle are equal to two angles and included side of other triangle. Here, there are two triangles A, B, C and D, C, B. Here, CB is the common one and angle ACB is equal to angle DBC. This is because alternative interior angles. Angle ABC is equal to angle DCB. This is because they are alternative interior angles. By ASA congruency criteria, we can prove that ABC triangle is congruent to triangle DCB. Next, AAS. It means that angle side. Two triangles are congruent if any two angles and a side are equal in a triangle as well as the other triangle. Here there are two triangles AOD and BOC. Here it is given that AD is equal to CB and OAD angle is equal to angle OBC and COB is equal to angle DOA. This is because they are vertically opposite angles. By AAS congruency criteria, we can prove that triangle AOD is congruent to triangle BOC. And the fourth angle is RHS. It means that right hypotenuse side. If in two right angle triangle, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle. In the image, you can see that triangle ABC and triangle EFC are two right angle triangle. Angle B is equal to angle F because they are 90 degree and BC is equals to FG as they are 8 cm and AC is equals to EG as they both are 13 cm. By RHS congruency criteria, we can prove that triangle ABC is congruent to triangle EFG. Now we can say that AB is equal to EF because they are the corresponding parts of the triangle. Next one is SS congruency criteria. It means that side congruency criteria. The three sides of one triangle are equal to the three sides of the another triangle. It means that the two triangles are congruent. Here you can see two triangles ABC and triangle XYZ. AB is equals to 8 cm and XZ is equals to 8 cm and BC is equals to 18 cm and XY is equals to 18 cm. YZ is equals to 9 cm and AB is equals to 9 cm. Since all these are the same, triangle ABC is congruent to triangle XYZ by SSS congruency criteria. Next topic is inequalities of triangle. There are two inequalities of triangle. First one is the sum of two sides is always greater than the third side and the difference of two sides is always less than the third side. AB plus AC is always greater than BC and AB plus BC is always greater than AC. AC plus BC is always greater than AB. Taking example of AB plus AC is always greater than BC. So AB is 15 cm and AC is 18 cm. The sum of these two is 23 cm, which is always greater than BC, that is 22 cm. Next one, AC minus AB is always smaller than the BC and BC minus AB is always less than AC. BC minus AC is always less than AB. Taking example of AC minus AB is less than BC. AC is 18 cm and AB is 15 cm. The difference is 3 cm, which is always smaller than BC, that is 22 cm. The second one is angle opposite to the smallest side is small and angle opposite to the longest side is big. In triangle XYZ, XY is the smallest side, therefore the opposite angle is Z, which is the small angle, and YZ is the longest side, therefore angle X is the big one.